Hello, today we want to talk about how to get the nice scatter plot in Stata. Based on that, we're going to talk about what's the problem with the scatter plot and further how to overcome that problem and how to solve it. Let's insert first the Excel sheet I created. Actually, you can download this Dofile in the description box. See there for further information, and also yeah, if you need a face to that story today, that's me. And now run the command. If you don't know how to do that by writing the command, you can go here on File, Import, Excel sheet, Browse, search for it, insert here, define your options, and then it should be no problem. So then we have the data inside, and then we play a little bit with it by typing in browse, and then we can have a first look on it. We see two variables, namely size of an apartment and the rent you have to pay per month. And we do have 9 observations for both variables. And yeah, we can further describe the data, and we see that same here, variable, label, size, and rent, and then summarize it. Then we see that we have 9 observations. The mean value of size is 68. The standard deviation 25, and we have the min and max value. Same also for the rent. And further in the do file, we can also label the variable a little bit better, than you can read it better. We have square meters and rent per month. And now we want to create a scatter plot. We do that here with scatter, then type in rent and size. You can also do that by double clicking on the variables. And that's the basic command. There are also options which we discuss in a second. And then it appears like this. And now we see, or let's have a close look for a second, but now we do see that we have 2 observations with the same square meters, but with the same with different rent per month, right? Here and also here. How could that be? Intuitively, we would think the higher the square meters, or the more square meters you have in your apartment, the higher is the rent you have to pay per month, right? But now assume you live in, for example, in let's say in Sydney in Australia, and you want to live close to Bondi Beach, and then it's reasonable that the rent per month increases, while on the same size the square meters goes down. So the further you live, the closer you live to the beach, the higher the rent, and the cheaper, the less is the size of your apartment, right? So what does it mean? That means we probably have an omitted variable bias, but that should be discussed in a second. I want to show you how to go further into details in the scatter plot. So if you don't know how to type your commands, for example, like scatter, you can also click here on graphics, and then actually you can do that with everything, but I do not recommend it, because if you go further into Stata and start your master thesis or your PhD program, it might be useful to know how to run and write your commands in the first place, and not use here the options you Stata provides, because it's get more complicated and it takes more time to find all the options here. But in this case, I'll show you, because it's not so hard. You click here on two-way graph, then create scatter, and then here you have for the y variable what we have here, the price, and then the rent, and then here the size. You click on accept, and then you have also here other options like titles. Let's give it a title, Sydney, subtitle, expensive question mark, and a caption and notes, right? It's quite clever. And also legend, but you can write that also in the command. And then it looks like this, right? Pretty cool, actually. And yeah, and then you can use that, for example, if you want to save that in your Dofile. Let's say we put it here. And if you need more help or more options, you can click, you can write scatter, help scatter, and then you have also a nice tool here and see marker options. Click that, then you come here, then you see you can change the size, the color, the shape of the scatter plot, and many more options. Check that for yourself. Further, what you can also do is sometimes it's useful to change the titles of the axis or even connect the single points. In this case, it does not make any sense, because what should the line tell you, right? But sometimes there are observations or data where it makes sense to connect that, but obviously not in that case, depending on your research. Yeah, and what if we go back and think about it, about the problem that we mentioned? If you live closer to the beach, you have to pay more for less square meters. Then we do have an endogeneity problem, meaning we obviously have an omitted variable bias that biases the specification of your mathematical equation, speaking in econometrically terms, right? And one variable that you could insert is range to the beach, and then might be a better specification, but the ordinary least square method might be based in many cases. So best way to overcome and solve that problem is actually to use one of the methods, like instrument variable, the difference in difference, the RDD design, and there are so many more, all depending on your research question and your available data. Of course, you have to think carefully about that. And yeah, we talked about that, the problem with the interpretation, causality versus correlation. So we do have a certain correlation here in that case, but it's not causal, obviously. Think about the number of births per month and the observed birds in the sky. So there might be a correlation, but it's definitely not causal, and that's what we do have here. But intuitively, we would think so, but in statistics or in math and economics, nothing that comes intuitively is sometimes is usually correct, right? Yeah. Now, last but not least, I want to show you how to run that regression if you want to have a simple regression. I usually run that without rec2, because then it provides you an output already. Then you run the regression. You want to have the effect of from size on rand, and then that's here the output table. But there's also a smooth way to do it better. That's why I use outrec2. And then you click here on see out. You can also click on the doc here, and if you do have Excel on your laptop, you could also open that in Excel. On this specific laptop, I don't have Excel, and yeah, that's pretty funny actually. So we click on see out, and then we see that we actually do not have any significant stars. I already have 4 columns because I did it 3 times before I recorded that video, and that's a smooth indicator that we actually don't have causality. Even though if you get 3 stars for significance level, it doesn't mean anything. I could create a nice data sheet where you can see every time 3 stars, like the number of birth, the number of giving birth and birds in the sky, right? So, but that raises the question, how could we establish causality? As causality is established when you argument on the research question or the hypothesis you want to test is the most plausible one, and if there's not any other argumentation that might be better. So it's not testable actually. You have to create your story around it, right? And then establish it with your argumentation and be really precise in that and be careful and always think, does it make sense what I write and what I try to run for regressions, for example? And let's go back to the Dofile. As said, you can download that in the description box. Yeah, that's pretty much it. What you might want to do is also to download the data in Excel. I put that also in the description box. You can check that out. And yeah, that's pretty much it for today. Thank you very much for watching this video. If you do have any questions, leave them below. If you want to see how to run one of those methods I mentioned, like instrument variable, then click on like that video or text me, whatever. Just write it in the comment box and I will see it, right? And yeah, okay, that's very much it. Thank you.